Are you getting pressure from finance to justify or reduce your cloud bill? CloudZero is the only cloud cost platform loved by engineers and trusted by finance. CloudZero can identify unused, idle, or over-provisioned resources, alert you to spend anomalies, and organize 100% of your spend into a framework that mirrors your business structure, like cost per customer, product feature, or team. It's the most powerful platform ever built to provide accurate, granular visibility into your total cloud spend without the typical pitfalls of legacy cloud cost management tools like endless tagging or clunky Kubernetes support. Manage cost, optimize development, and maximize profit, all in one platform. Join companies like Rapid7, Drift, and SeatGeek by visiting cloudzero.com/cloudcast to get started. That's cloudzero.com/cloudcast. Visit today to experience immediate and ongoing savings on your cloud bill.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for Cloud News this week, and it is the beginning of June. I can't even believe that. But we've got some really good cloud news articles this week, but I also feel like we need to mention the elephant in the room. Certainly not enterprise tech, but certainly emerging tech. Apple announced their AR/VR headset. I don't know. Won't be out for another year, and when it does finally come out, no one will be able to afford it. So we'll see. I don't know what else to say beyond that. So we're just going to jump right into our news this week. First article this week, Reddit announced earlier that they are going to start charging for API requests. And this is a trend we're starting to see. And this is a larger shift in the market. A lot of organizations that were supported by ad revenue previously, some of that ad revenue with the changing economy starting to dry up a little bit. So what are some ways that they can make money? Well, APIs kind of makes everything go round. We've talked about it many times on this show. It's the way organizations are talking to each other. It's the way everyone's accessing their data. And oh, by the way, it's where a lot of the security impacts are happening as well. But Reddit is looking to charge somewhere in the neighborhood of $12,000 for 50 million API requests. Now, that, sounds 50 million. That sounds like a big number. But, for instance, there was a vendor in the article that they would be looking at 7 billion requests a month. So about $1.7 million per month, or about 20 million per year for them to continue to do API requests against Reddit. So some pretty significant impacts to this. And there's lots of protesting about it. There's lots of subreddits going quiet. And it'll be interesting to see where this ends up. Now, the next one, and this is actually, I don't know who is in charge of PR over at CoreWeave, but kudos. So on Wednesday, they announced a $200 million funding round. And if you're not familiar with them, think of them as a vendor that specializes in providing and partnering with NVIDIA for GPUs. And really powering a lot of the folks that are looking to do OpenAI and ChatGPT in particular. So they announced a $200 million funding round on a valuation of $2 billion. And then they also announced, hey, by the way, we're partnering with Microsoft. And so Microsoft actually probably secured this earlier this year, but it came out as well at the same time. Microsoft is, struggling with the demand of OpenAI. So how can they ensure pipeline and ensure continued growth? Well, they partnered with CoreWeave. So really good, interesting partnerships happening and funding rounds happening. And CoreWeave, for instance, brought out the new cutting edge NVIDIA GPUs. And I talked about that in a Cloud News article, 2-3 months ago, somewhere thereabouts. So good for them. They're certainly killing it. And they had a hell of a week. And for our third and final article, GitLab really did well from an earnings standpoint. They reported earnings and they beat guidance. So what do you always want to do when you're reporting earnings? You want to beat and then you want to raise expectations. Well, they did both. They beat guidance and they raised expectations for the year. And because of that, their stock went on a healthy jump, and certainly good for them, and wish them continued success. If you want to dig into the financials deep, you can, of course, look at the Cloud News show notes, and this and all the other articles are in depth in there. So with that, I'm going to wrap up Cloud News for this week. And coming up after the break, we're going to be talking about economics and beyond, about object storage. And we're going to be talking to Jon over at Cloudian about it.
Today's episode of the Cloudcast is sponsored by Datadog, a real-time monitoring platform that unifies metrics, traces, and logs into one tightly integrated platform. Datadog APM empowers developer teams to identify anomalies, resolve issues, and improve application performance. Begin collecting stack traces, visualizing them as flame graphs, organizing them into profile types such as CPU, I/O, and more. Teams can search for specific profiles, correlate them with distributed traces, and identify slow or underperforming code for analysis and optimization. Plus, with Datadog APM Live Search, you can perform searches across the full stream of ingested traces generated by your application over the last 15 minutes. Try Datadog APM free with a 14-day trial, and Datadog will send you a free t-shirt. Visit datadog.com/APM-Cloudcast to get started. That's datadog.com/APM-Cloudcast.
And we're back. And what we're going to do this week is really explore a topic that's, as a technology, been around for quite some time. But we want to do a little bit of a different spin this week. We want to talk about object storage, but we want to talk a little bit about economies of around it and what has kind of happened over the last 10 plus years and what the future is for object storage as well. So in order to do that, we went out and found an expert, like we tend to always do here on the show. And so we have Jon Toor, CMO at Cloudian this week. Welcome to the show, Jon, and tell everyone a little bit about your background.
Well, hey, thank you very much. And it is great to be here. I guess my background could be really summarized very quickly. It's basically all storage all the time. I began my career actually as a design engineer on hard drives with Seagate, when Seagate was a tiny little company based on a small town near here where I live in Los Gatos. They were in Scotts Valley. And my storage career progressed through hard drives in the engineering side into hard drives on the marketing side, and then systems on the marketing side. And that's really kind of where I've stuck ever since. I've done a few different startups. I've been involved in a few large companies, so a lot of variety, but it kind of all revolves around storage.
Fantastic. And Cloudian is really interesting to me for multiple reasons. And I believe like your career and Cloudian kind of parallel in many ways. Cloudian, first of all, has kind of been around, I'll say, since before object storage was cool. When it was kind of an emerging technology way back when. And we first heard about Cloudian back in the OpenStack days. And for longtime listeners, they'll remember that in early AWS S3 days. And so object storage certainly has come a long way. And so can you help everyone frame like where were we and where are we today?
Yeah, one thing that's generally true about storage technologies is they tend to have a very long gestation period. They sit on the shelf being relatively unused for quite a long time before a use case comes along that really drives adoption. Fiber Channel was exactly the same way. It sat essentially on a shelf out in Minneapolis for many, many years before parallel SCSI ran out of gas and there became a need to do something new and different. Well, object storage is the same way. Object storage, as you rightly pointed out, started a long time ago. It actually started as a way of making data immutable. It was introduced by EMC commercially as a system to protect healthcare records so they couldn't be changed. And that was, definitely a use case, but it wasn't going to drive any large-scale adoption. Well, what happened was, as we progressed through block storage, file storage, and then into the cloud providers recognized that they really needed a extremely scalable storage environment to meet the needs of their cloud customers. I mean, you were not going to be able to build a hyperscale environment on file. In fact, the last major cloud provider that was built on file was Yahoo. Every major cloud provider after that was built on object storage. So they saw the need to do things at a totally different scale. That drove adoption of object storage. And what came along with it was that object storage became endowed with a whole bunch of cloud capabilities. So you got really two things. You got the underlying technology, object storage, and then you got this protocol, this API, which is now adopted as Amazon AWS S3. And that endowed object storage with a whole bunch of cloud capabilities that made it multi-site, multi-tenant, gave it multi-part upload capabilities, which was really important for moving large files over the internet. So you got really this set of use cases of cloud demands that made object storage something completely different than what it started out as, and really made it the storage of the next generation.
And I'll add to this too. I think the object storage, to your point, was always there, but I think it was the S3 compatible APIs that really solidified the use cases are kind of across the board, right? And so ever since then, we've seen this rise of what I'll just term enterprise class S3 compatible object storage, right? And that's where the use cases really started to explode. You see hybrid cloud, you see especially data sovereignty these days with data sovereignty laws. And most recently, analytics, such as data warehouses, data lakehouses kinds of things popping up as well. And so where are you seeing implementations these days? And because we've really moved beyond basic, simple storage for the cloud backends, right?
Absolutely, and that's been a really interesting evolution around this. And storage is always driven by the use cases. You have to have the use case demanding the capabilities of this class of storage before a customer is going to go out and buy it. No one adopts a new technology and then waits for the use cases. They counter the use cases and then they adopt the new technology. So that's exactly what's happened here. And what we've seen is that as these use cases have become cloud enabled, that's really what's driven the adoption of object storage. And let me tell you what I mean by that, cloud enabled. So backup is a classic example, because when you're looking to back up your data center, you need a target, right? The data has to go somewhere, and cloud emerged as a good target for backup data. So as a result, all of the enterprise backup vendors adopted the S3 API as one of their supported protocols, so they could use the cloud as a backup target. Well, obviously, once you've adopted the S3 API as a protocol, you can now put that data anywhere that has S3 compatible storage. It doesn't have to be in the cloud. It can be on-prem just as easily. So because the backup vendors all went and did that, it emerged, backup emerged as one of the key use cases for S3 compatible storage on-prem. Well, we've seen that same thing happen, as you already said, with data lakehouses, analytics. All the vendors in that space also are looking to make their software be cloud enabled. And so that's another emerging use case. And we're seeing this across the board. We're seeing this in M&E. We're seeing this in healthcare. We're seeing it in all kinds of data analysis software. Everyone is looking to make their software cloud enabled, but when they do that, they're also making it just S3 enabled, so we can deploy S3 compatible storage on-prem and get this exact same benefits.
And kind of an aside to that, because you did mention this earlier as well, and it just kind of popped into my head. Tell everyone a little bit too, because I think, again, go back to the early days of all of this, and it's the more simple storage aspects of all of this. We started to see some security concerns early on, right? And then you start to see data privacy, the rise of that. And as I mentioned, data sovereignty as well. And so how big of an issue these days, other than, obviously very large, is security in all of this? And how has the evolution of security as, more copies of data kind of get in more places?
Yeah, it's huge. The security issues and the concerns that customers have are huge. But interestingly enough, this is an area where S3 compatible storage really can shine because, well, first of all, think about ransomware protection, for example. To protect your data from ransomware, the best way to do it is to make it immutable, right? If you can make it a copy of your data that's unchangeable, ransomware cannot go in and encrypt your data. It's not possible. And so as a result, your data is protected from the most common form of ransomware hacking. Well, as I said up front, actually that was the original use case of object storage, was immutability. That's what EMC sold it as, 20 plus years ago. And interestingly enough, AWS with S3 improved on that with a standard for how you manage that immutability. They created a protocol called object lock that made it possible to manage that immutability feature in a standardized way. So as a result, the backup vendors adopted object lock as one of their APIs. We implemented object lock, and it's been a key driver of data protection on S3 compatible storage. Because you can protect your data from hacker intrusion, it solved one of the big problems we saw happening when COVID started coming along. Right? When COVID started, we saw an enormous uptick in ransomware attacks because of people working from home. They became more vulnerable to email phishing attacks, et cetera. So that became a huge driver. But security overall, and this kind of gets into that next thing. Kind of where is object storage going? Object storage is becoming the de facto for private clouds of all kinds, and data sovereignty is a major use case for private clouds. So you think about governments or highly regulated industries who need to keep their data in specific environments because of regulatory concerns, just pure geographical boundary concerns. They want to create a private cloud to manage that data. Well, obviously, what they're concerned about with that data is sensitivity, right? That the government's got government records, it's got healthcare records. So protecting that data becomes job one. You've got to make sure that data is secure, and it's got to be bulletproof. So you want it to be secure, but at the same time, you want it to be accessible because you're putting it in this private cloud. The whole point is to make it accessible by the people that need to use it. So you can't rely just on the confines of the data center. You got to have security protocols that are best in breed and can be used when they're accessing the data from anywhere. Well, that's exactly what we have implemented with Cloudian. We have more security certifications than anybody else in the business. These are government security certifications set by the SEC, set by the Department of Justice, set by the government agencies that buy this kind of storage and use it in their own private clouds. Cloudian was the storage of MilCloud 2, and we just announced we want to deal with the Department of Defense for their new version of their government cloud. So security had been part and parcel of our message for years now, and we worked very hard to enhance that story. So basically what we've got is a private cloud, which is as secure or more than the best, most secure data environments you can buy anywhere. And what that means is now you can set up the sovereign cloud environment in your data center and know that that data is protected from ransomware attack. It's protected from external attacks, from people coming in from the outside, and it's protected even from people within your own data center. We lock down the box itself by disabling root access, such that even if you have physical access to the box, you don't have a way of tampering with it. So we've addressed this from all levels, and what that's done is it's made us a great solution for these sovereign cloud environments, and we're currently in environments in Germany, in New Zealand, in Australia, in several different companies in APAC, countries in APAC, other places in EMEA. Sovereign cloud has emerged as being a really important use case for S3 compatible storage, and security is one of the key reasons why.
Fantastic. And I'll add this too. Like we'll dig into another topic here, which is cost and cost effectiveness. Because if I look at, like take the last KubeCon here in the United States back in Detroit, one of the big, themes, if you will, was cost. Another big one was security. And especially with the economic environment's changing slightly, like interest rates starting to go up, and VC funding isn't quite as loose as it used to be, and interest rates going up. There's a lot of folks really starting to figure out, okay, how do I secure everything, but how do I also make sure the economics make sense? And so we're starting to see this more in design conversations, but I'll just say there's always a healthy tension, if I use that term, between what's technically possible and what's economically feasible. Just because something can be built doesn't mean it's economically viable at times. And so how does that kind of design conversation play out lately?
Well, that's been a very interesting dynamic over the past, 3-4 years. Object storage has always been a highly cost-effective platform because it's built on industry standard hardware, and that's been true, for many, many years now. So our underlying hardware platform is very cost effective. Our software itself tends to be very efficient and low overhead in the way that we, store the data and protect the data. So the cost of object storage versus other storage types has always been very, very competitive. Matter of fact, we're substantially less expensive than most file or block systems. So if you just compare apples to apples, our storage class versus others, that's always been an easy conversation. You're gonna save money with object storage. The conversation that's become right on front and center of people's minds has been, well, what about cloud, right? Because if I go to cloud, then I'm purely on a OpEx model. I only pay for what I use, and I can have the flexibility of growing without ever having to lay out any additional capital expense. And that's obviously been an interesting conversation. And at the start of COVID, that conversation took on a new dimension, which was my on-prem data center has become hard to manage, right? Getting people to go into my data center to run it, to install new stuff, to maintain it has become difficult. And so that made the cloud, that tipped the hand for the cloud during that conversation. Fast forward a few years, though, now we're moving out of that era. What we've seen is this. What we've seen now is that on-prem object storage and cloud have both become so similar in so many ways. We use the same API. We offer the same kind of enterprise scalability. We really made a very different kind of storage environment that parallels very much the capabilities of cloud, but with one key difference, and that is, we are primarily a CapEx model where you're buying the equipment up front, whereas cloud continues to be an OpEx. So depending on your use case, one could end up being substantially less expensive than the other. And what we're seeing is customers are now evaluating their use cases. They're now looking at, hey, if I know what I'm going to be consuming, I know I can predict my storage requirements because I'm managing a large data set that is of a fairly known size. It's likely it's going to be a lot less expensive for me to operate my own environment than it is to go out and buy it essentially in a rental, buy it by the drink in a public cloud environment. So what we're seeing now is customers are making that assessment rather than just saying, you know what, I'm having trouble running my own data center because of staffing, because of COVID's constraints. Now they're saying, I need to make a decision per use case on where it makes sense for me to run this workload. And that decision could be driven by data sovereignty. That decision could be driven by cost. That decision could be driven by latency, right? Depending on where that data is being sourced and where it's being used. And based on those requirements, I'm going to make a decision on where I should run that environment. So it's no longer just let's just go to the cloud. Now I've got a choice of exactly where I run this, and I don't have to make it a choice based on technology. because I can run the same data types, I can run the same applications on-prem or in the cloud, and I can manage them the same way. So technology is no longer necessarily a driver in this. Maybe in some cases, but in many cases, I can do the same thing either place. So it really comes down to, where does it make business sense to run this application, to run this workload, and what's the best way of going and doing that? And that's where object storage is really kind of emerging as being the on-prem cloud. And that's why hybrid cloud is such a key part of our messaging, because what we're saying is, if you've got workloads that can run in a cloud-enabled way, you have a choice. You can run those workloads on-prem, do the math. Does that make sense for you? Or you can run them in the cloud. And what we're seeing now is customers are very much making that choice based on some pretty serious analysis of their workloads.
And I'll add maybe a potentially another vector to that, because this is what as you were talking about that, there was a term that was really thrown around a number of years ago, and I haven't heard it nearly as much recently, and that's the term of data gravity. And so the concept, for those unfamiliar with it, is this idea that data has a certain amount of weight, a certain gravity, and it attracts more data to it. Existing sources become hard to move over time, and then more and more tends to get added to it. And so what we, especially with, I would say, the rise of hybrid and multi-cloud, folks don't think about it or talk about it as much. We used to talk about, make sure you're placing this in the right locations, and you had the ingress and egress charges and all these other things to think about. Well, now we're in an environment where we are seeing more hybrid and multi-cloud solutions. We are seeing larger and larger data sets. And so where are folks building these large data sets, and what are they building them for? And last question, are they ever moving them? Or is it, more of the latency is good enough kind of scenario?
Yeah, data gravity is definitely a driver. Large data sets are difficult to move, and as a result, the industry has developed all kinds of physical workarounds, including putting storage in trucks and moving them that way. The old joke, you can't beat the bandwidth of a station wagon full of tapes moving down the highway. That goes back a lot of years to when we had station wagons. But the same is true now. Even in the post-station wagon era, people are still moving their data in trucks for the same reason. And it does happen. And data gravity is absolutely a concern. When people are collecting a lot of data in one place, it is certainly easier to just leave it there and operate on the data there. And now, because you have the ability of running that workload, whatever that workload is, if it's a cloud-enabled workload, you have the ability to run that workload wherever the data is. That decision just got a whole lot easier, right? You no longer have to worry about, how am I going to move that data? You say, well, I can bring the workload to the data. I don't have to change I don't have to change the software. I can run things the same way. I can just do it close to the data. So that conversation has actually gotten easier, but it's also taken on new dimensions, because data gravity is not only the size of the data, but it's also the physical location of the data versus in relation to what that data is. So TikTok is the classic example right now, right? They've got all this user data, and the question now is, where does all that user data reside? And so that's what TikTok's Project Texas is all about. Is we're saying, well, that user data is now going to reside in Texas, because that's going to alleviate the privacy concerns. And that's really become more the compelling issue today, about where does that data physically reside, and how do I make sure that I'm complying with the data sovereignty requirements. So I would say data gravity, ability to move data is probably important. Data sovereignty today is probably even more important. Latency is always a concern, right? If I'm running a workload in a clinic, for example, I'm trying to access healthcare records or images. If those images are stored in the cloud, how long is it going to take? Well, if that cloud is in, for example, in Singapore, where the AWS region is for that area, and my application is in Vietnam, and I'm having to move that data back and forth in undersea cables, what's the latency involved in that? How quickly am I going to be able to access that data? So that's definitely a point of conversation today as well. And then finally, the cost. So I guess the point is that data gravity now has kind of multiple dimensions. And all of these things are saying, I need to factor all these things in when I decide where I'm going to run the application. And that's where hybrid gets so important, because now you can say, well, I can run that application wherever it needs to be. I don't have to change the software. I don't have to change my processes. I can run the application close to the data, and the conversation just got a whole lot easier, and I'm potentially saving myself some money at the same time. So it's a win-win.
Very nice. Very nice. So Jon, one last question for you. And maybe this is also some advice for, other folks starting companies or thinking about business. We like to approach the business side of this as well. And so Cloudian is really well known for their partnerships, their alliances, and their solutions, right? You have quite a mix. And part of that maybe just goes back to being a startup that has been around a lot longer than other startups. But if you look at the mix, right, there's hardware companies, there's software companies, there's backup companies, there's public clouds. I mean, there's a little mix of everything and anything in there. And so has this been, first of all, intentional and a factor in Cloudian's longevity? And tell everyone a little bit about this, how this came to be and how important you see this for the future.
Yeah, we are so very proud of our alliance partners, because they're really key to our business. And really, I can think about these in three categories. The first would be their alliance partners that are related to our use cases. So the most obvious example would be backup, where we work very closely with Veeam and Rubrik, and Commvault and Veritas. And working with those partners is so important, because that our ability to integrate with them to provide a solution which is plug and play and really satisfies the customer's needs in the least cost, in the most cost effective and in the most performant way has been really critical. So working closely with those guys has been so important to us. And then we're seeing it now with the analytics vendors, working with folks like Teradata and Vertica and Cribble and Splunk, and working in the analytics world. Microsoft SQL is now a partner of ours, and Microsoft SQL adopting the S3 API. There's an amazing one for you. So working with those partners has been a key to driving our use cases. The second thing is channels, because we need routes to market, and we are always sold as part of a larger environment. Obviously, it's never a standalone thing. It's always a larger solution. So working with folks like Lenovo and HP GreenLake, we're now part of the HP GreenLake environment, has been so important, because they're great channels into that market. And then the third area is kind of a catch-all, and that's hybrid cloud. Because as the cloud providers start looking at how they provide services closer to their users, so they can address data sovereignty concerns, for example, we are a solution for that S3 storage that is local to the user. So we're working with AWS on Outposts, which is their hybrid cloud solution that's on-prem. We're also working with AWS on Local Zones, which is their sort of mini region that sits closer to the user, but provides capabilities just as if you were in an AWS region. So we are storage for Outpost. We are storage for Local Zones. So working in these hybrid cloud environments with AWS and others is a really critical one. And I would put in that same category, we work with cloud providers worldwide to provide cloud services that they turn around and offer, including some of the largest in the world, like Ionos over in EMEA, massive cloud provider that relies on Cloudian as the underlying storage infrastructure for object storage. So those hybrid cloud environments, private cloud environments are the third class of major partnership. All of these are really critical to driving our business, and we work really hard to make sure we have a well-integrated and well-supported solution for each of them.
Fantastic. Well, with that, I think that's a great place to really close this out. Jon, I just wanted to say thank you very much for your time this week and your insights on all of this. And everyone that's out there, thank you very much for listening. And if you enjoy the podcast, please leave us a review wherever you get your podcast. Please tell a friend, and we certainly want to continue to grow the community. And if you have any feedback, certainly reach out at any time. And so on behalf of Brian and myself, thank you, everyone, for listening, and we'll talk to everyone next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.